Oak Creek Homes of Lancaster 101 class in moisture prevention. Moisture problem prevention. Notice the areas of concern. Darker area, very high risk of summer moisture problems, followed by moderate to high risk for summer moisture problems. First, we will go over the manufacturer's checklist in detail. These are the items that we can control in the manufacturing process to help reduce moisture problems from the beginning. The manufacturer's checklist. Minimize ceiling penetrations. Insulate the outside walls and ceiling without voids or compression. Reduce opportunities for air leakage through the walls. Seal ducts to make airtight, durable connections. Specify production details that minimize moisture damage. Minimize ceiling and floor penetrations. Penetrations in the floor and the ceilings are natural pathways for moisture vapor migration, resulting in condensation and mold in the floor and in the ceiling areas. Proper sealing of the floor cavity and the ceiling penetrations. These include: seal all penetrations through the floor. The floor is a natural moisture and air barrier. Keep it intact by sealing all floor penetrations with the appropriate sealant or gasket. Gaskets for plumbing penetrations. Foam for electrical penetrations. Caulk for register penetrations. All levee and kitchen floor penetrations should be foamed. All levee and kitchen floor penetrations must be filled with foam to stop air infiltration. Insulation is a great alternative. Insulation must be packed if used correctly. All tub and shower and washer at floor locations outside or the inside of walls must also be foamed for air infiltration. All large hole electrical penetrations at the floor panel box area should be foamed for air infiltration. All vent through the roof at the ceilings should be foamed as well to prevent air infiltration. Humid outside air can enter an interior wall cavity through poorly sealed holes for wiring or plumbing. Moisture condenses on the cold wall. The moisture cannot dry through the vinyl, causing the interior wall to swell. All P-trap penetrations will be sealed with insulation. Insulate walls, ceilings, and floors 100%. Any gap or void can result in cold or hot spots that will encourage condensation and mold growth. A void like this could be catastrophic in a very hot environment. Heat from outside of the house coming into a cold environment will produce condensation, which could lead to deterioration or mold. This ceiling void could lead to heat loss, condensation, and possibly deterioration of the ceiling board. Floor void. In a cold environment, this void can cause the plumbing to freeze and break and cause water to leak into the belly, causing deterioration. In a hot environment, this void will cause condensation, which will lead to deterioration and mold. Make sure that you have the right size equipment for the right size of the home: air conditioner and condenser unit. Oversized cooling equipment, air conditioners, and heat pumps cycle on and off frequently and do a poor job of removing moisture from the air. Excess ventilation in a humid climate can overwhelm the dehumidification capacity of the air conditioning equipment. Carefully plan the air supply and return air registers. Ensure adequate register size and avoid locating registers near sources of water, for example, showers and tubs. Provide adequate return air grills from the bedrooms, especially master suites. Seal ducts to make airtight, durable connections. Seal edges with mastic before assembling register mixture boxes. Apply heat duct tape to edges and smooth with the squeegee. In case there is a gap at the end cap, fill with mastic and apply heat duct tape. Insert the end cap, apply heat duct tape, and smooth tape with a plastic squeegee. Apply heat duct tape at leftover joints and smooth with a plastic squeegee. Cut the appropriate size hole per print with the HVAC knife. This is an HVAC knife. Use a liberal amount of UL 181 duct mastic in a tube around the edge of the collar. This is UL 181 duct sealant in a tube by LaSalle. Bend your tabs back into the inside of the HVAC material to where it pulls the collar tight and the mastic forms a gasket seal. Apply the mastic to the outer collar and wipe the mastic to seal the outer collar to the box. Apply UL 181 duct mastic 100% around the collar. Next, smooth with mastic with an applicator to control coverage. Install the inner hose pipe around the collar all the way to the top and install the zip tie with a tensioner tool. Always install the zip tie as close to the top as you can. Note, make sure mastic is wet before installing the hose. Make sure to pull up the insulative sleeve and cover up as much metal collar as possible. Pull the outer sleeve over the insulation and zip tie the sleeve. Please make sure that all register boxes are sealed at the seams. Note, done in the mud pit. Make sure the register box is completely foam sealed, no gaps. If you have a void, fill it with foam seal or UL 181 duct mastic. Second, we will start off with an installer's and HVAC contractor's checklist. Specifically, ensure that any tears or gaps in the bottom board material are durably sealed. Make sure the dryer exhaust duct is supported and installed correctly. Properly size cooling equipment, and in humid climates, recommend equipment with higher latent movable capacity. Make sure that the site is properly graded. Water draining under a home can destabilize the foundation, as well as increase the chance of moisture migrating into the house. Here's an example of poor grading. Bare ground, water that pools under the home, water slopes towards the home, no crown, no gutters. Install a ground cover. Installation of a ground cover is one of the most overlooked and underestimated setup tasks. Water vapor from the ground is often the largest source of moisture load on a house. Ground cover. The ground cover of a minimum of 6 mil, 0.006 inches thick, black polyethylene, or proved equal, shall be laid over the ground within crawl spaces. The ground cover shall be overlapped 12 inches minimum at the joints and shall extend over the top of the footing. Side note, our setup guy says that the joints should also be sealed with mastic. Ensure that any tears or gaps in the bottom board are sealed. Water vapor from the ground will find its way into the floor cavity through tears, cuts, and holes, adding to the house moisture load and condensing on cold surfaces. Make sure to re-insulate and patch any open holes in the bottom board. Please use Q320 spray adhesive in a can or an equivalent for any bottom board repair. Once you have replaced the insulation, spray your adhesives on both sides of your patch. Always make sure to spray both the patch and the cut or the tear. Notice no gaps at any edge. Make sure that the dryer duct is supported and installed properly. Like a drain pipe, the dryer duct needs to be sloped downhill and have proper support. Water can easily condense inside the duct, blocking airflow and allowing moist, drier exhaust air under the home. Make sure the air conditioner condensate line is properly trapped and terminates outside of the skirting. Improper drainage to the condensation lines can create water pooling under the house and sending moisture back inside the house. The marriage line should be sealed completely. A non-porous gasket should be placed along the inside edge of the insulation in a continuous ring to prevent air and water vapor from infiltrating into the home and wall cavities. How to air seal the modular home marriage joint. Install a gasket along the entire seam of the marriage joint. If the manufacturer has already installed the gasket, ensure that each step below was performed. Install the gasket to the ceiling, walls, and floor prior to joining the sections together. Fold the gasket in half and fasten along the mating surface with nails or staples. Fasten at intervals of 6 inches on center. NFPA 2013. The homeowner's checklist. Specifically, when it comes to the size of your air conditioner or heat pump, bigger is not better. Do not cover or close off floor registers. Keep the thermostat set above 75 degrees Fahrenheit in hot, humid climates. Eliminate moisture problems at the source. Any moisture problems begin with excess amounts of water dumped into the air by common household activities, such as cooking and bathing. Ventilation fans should be turned on during such activities and be left on for a short duration after the moisture-producing activities cease. Check your cooling equipment and filter monthly. Clogged filters can interfere with an air conditioner's ability to remove moisture from the air, and in some cases interfere with condensate drainage. Dirty filters should be either cleaned or replaced. Consider using pleated filters for better dust control and better dehumidification. This is a floor duct scenario, but upflow will have the same effect. Clogged filter blocks airflow. Air conditioner A-coil, the drip pan, condensate leaking into ducts or onto the floor. Air pulled up from the condensate line, preventing it from draining. Water leaking into ducts. Water leaking from the drip pan. Keep the thermostat set above 75 degrees in hot, humid climates. Keep the thermostat setting at or above 75 degrees in the summer. In high humidity climates, a lower setting could cause water to condensate inside the wall cavities. The key to solving moisture problems is to understand, number one, why moisture has accumulated at the damage site. Number two, where the moisture is coming from. Number three, when the source of the damage is physically removed from the site of the damage, how the damage travels from one place to the other. Effective moisture control can be achieved consistently and is the result of good design, careful installation, and intelligent home operation. Thank you.